We're on lesson 6 of chapter 9, which we're going to solve quadratic equations by the quadratic formula. First, we're going to solve using the quadratic formula. Then we're going to choose a solution method. Then we're going to solve a real-world problem. So after all this work of factoring and finding square roots and completing the square, we're finally going to teach you a nice, simple way to solve all of these different quadratic formulas. This might make you a little angry to know that there's been this formula this whole time to solve these quadratic equations. It's called the quadratic formula. So the solutions for a quadratic equation, ax squared plus bx plus c equals 0, can be found using this quadratic formula. It's x equals negative b plus or minus the square root of b squared minus 4ac over 2a. This will be one of the more useful tools for you to remember for the rest of your math careers. So I would actually recommend studying this and memorizing it. It'll make your life a whole lot easier. Let's just use an example here. We have 2x squared minus 7x plus 3. So if we plugged in all the b's and the a's and the c's into this formula, we would get this. Negative 7, which is positive 7, plus or minus negative 7 squared minus 4 times 2 times 3 over 2 times 2. Negative 7 squared is 49, minus this would be 24, so that's 25. Square root of 25 is 5, 2 times 2 is 4. That leaves you with 7 plus or minus 5 over 4. And that's where we get our two answers. If we add 5, 7 plus 5 is 12, divided by 4 is 3. 7 minus 5 is 2, divided by 4 is 0.5. Just because we're learning the quadratic formula doesn't mean that we're always going to use it. Sometimes it is better to use other methods, the ones we've learned so far. For example, it's easier to factor when the quadratic equation can be factored easily. Like you could just factor out an x squared or an x, or maybe it's one of those where you can find the product and sum pretty easily in your head. Sometimes it's best to use graphing, especially when you just need to find an approximate solution. You could graph it on your calculator and then find the x-intercept. Finding square roots can also be good if you can write the equation in the form of x squared equals d, where you just got to find the square roots of both sides. Completing the square could also be used for any quadratic equation, but the simplest to use it is when a is 1 and b is an even number, because remember you have to split this b in half. But also you can use the quadratic formula for any quadratic equation. So let's use it. We have 3x squared plus 5x equaling 8. And we want to solve this using the quadratic formula. Well, first let's write this in an equation where the answer is 0. So I subtracted 8 here. We have 3x squared plus 5x minus 8 now equaling 0. We'll write the quadratic formula up here. Negative b plus or minus the square root of b squared minus 4ac, and that's over 2a. So plugging in our numbers, b is 5, so we have negative 5 plus or minus the square root of 5 squared minus 4ac minus 4 times a, which is 3, times c, which is negative 8. Extend our square root sign here. And that's all over 2a, so 2 times 3. 5 squared comes out to 25. 4 times 3 times negative 8 equals negative 96. So I have 25 minus negative 96. That's going to equal 121. So if I rewrite my formula here, I have negative 5 plus or minus the square root of 121 over 2 times 3, which is 6. Square root of 121 is 11, so we have negative 5 plus or minus 11 over 6. And here's where we can get our two answers. Remember, this is x equals this. So when it's plus 11, I'd have negative 5 plus 11 equaling 6, divided by 6 equals 1. So x could equal 1. So when it's minus 11, I have negative 5 minus 11 equaling negative 16 over 6. That'd be negative 16 over 6, which we can simplify to negative 8 over 3. So x would be negative 8 over 3. So by using that quadratic formula, it took us a few steps, but we figured out the two answers using that formula. Now let's solve this one. This one is also not written properly, so we'll subtract the x from both sides here in standard form. So we have 2x squared minus x minus 7. Plugging in our numbers then, we have negative b, which is negative 1, so that becomes positive 1, plus or minus the square root of b squared, so negative 1 squared, minus 4 times a, which is 2, times c, which is negative 7. And that's going to be over 2 times 2 because a is 2. If we do our math here, negative 1 squared is positive 1, minus 4 times 2 times negative 7. That's going to be minus negative 56. So this is like 1 plus 56. So this would give us 1 plus or minus the square root of 57 over 2 times 2, which is 4. So this is all going to equal x here. So when I do 1 plus the square root of 57 divided by 4, I get an answer of positive 2.14. So x equals positive 2.14. When I do minus the square root of 57, 1 minus the square root of 57 divided by 4, that gives us negative 1.64. So these become my two answers for x by using the quadratic formula. So we found these ones using the formula, and now we found these ones using the formula. For these ones, we actually don't even need to solve. We just need to tell the choice that we would use to solve this quadratic equation, and then explain why we chose that one. So we have 10x squared minus 7 equaling 0. I see that I could write this one very similarly to this one, where we can write it x squared equals d, and we could just find the square roots of each. To do that, we'd have to add 7 to both sides, so it'd be 10x squared equaling 7, and then divide both sides by 10, leaving us with x squared equaling 7 over 10. Then that'd be pretty easy to solve using the square roots method. And that's all I'm going to say for my explanation because I showed my work a little bit. Here we have x squared plus 4x equaling 0. Here I notice I'm missing that c, so what we could do is we could add that c in there, which would make this work, such as 2 squared. We'd have x squared plus 4x plus 2 squared equaling 2 squared. And if you paid attention to last lesson, you notice that that's completing the square. We did completing the square. And just like the last one, I'll let my work be my explanation. Here I have 5x squared plus 9x minus 4 equaling 0. I don't know about you, but I can't do this one in my head. It seems pretty difficult, especially with that 5 for the x squared. So in that case, I'm going to choose the quadratic formula. And that's going to save me a lot of time just solving it that way. Now we can solve a real-world problem. From the period of 1971 to 2001, the number y of films produced in the world can be modeled by the function y equals 10x squared minus 94x plus 3900, where x is a number of years since 1971. In what year were 4,200 films produced? So we're trying to find the year when it's 4,200. And then x is the years, so what year would that make that? So we have 10x squared for our equation, minus 94x plus 3900. If we subtract the 4200 from both sides, that's going to give us negative 300. So we have 0 over here equaling 10x squared minus 94x minus 300. And this looks pretty difficult to me, so let's use that quadratic formula. So we have our formula of negative b plus or minus the square root of b squared minus 4ac over 2a. So if we plug in our numbers, negative b would be positive 94, and that's plus or minus the square root of negative 94 squared minus 4 times a, which is 10, times c, which is negative 300. And that's going to be over 2a, which is 2 times 10. Doing this math, negative 94 squared minus 4 times 10 times negative 300, I'm going to do that on my calculator. And that gives me an answer of 20,836. So we have 94 plus or minus 20,836 over 20. So if I add the square root of 20,836 to 94 and divide by 20, that gives me an answer of positive 12. So x could equal 12. If I subtract the square root of 20,836 and divide that by 20, that gives me an answer of negative 3. And I think we've figured out by now when you get these two answers, one of them is going to make sense and one of them won't. if this is the years from 1971 to 2001, we're not measuring 1968, which would be 3 years before that. We're measuring 12 years after that, so that would be 1983. So in 1983, they produced 4,200 films.